All right, ladies and gentlemen, so welcome to the first review answer key for this school year. Normally when we do these, because there's a lot of things to work out and show formulas for, it'll be a blank version and I'll kind of do the work problem by problem. But for this one, since it's a lot of written things, I'm just going to kind of go over it, show you this. We went over it in class. If you weren't here, maybe this will help. So the first thing you have, all horses are mammals. Just remember the horses. Being the horses provides your hypothesis. The fact that they're mammals gives you your conclusion. So the first one, if the animal is a horse, then it is a mammal. That's true. Converse, you flip that order. So the conclusion goes to the front, hypothesis to the back. If the animal is a mammal, then it is a horse. That is false. Main thing we want to do here with explaining false is you want to keep the idea of the hypothesis true. So find an animal that is a mammal but is not a horse. So basically any other mammal that's not a horse. So my example, a dog is a mammal but not a horse. Okay? Or you can name any other animal, just one example. Inverse, if the animal is not a horse, then the animal is not a mammal. Also false. Okay, keep this true. Name an animal that's not a horse. A dog is not a horse. Is it a mammal? It actually is. So that's why it makes the inverse false. Contrapositive, if the animal is not a mammal, then it's not a horse. If you're not even starting with mammals, then you're definitely not a horse. Okay? Biconditional. Get rid of if then. All right, I was interrupted, but let's get back to this. The biconditional hypothesis, animal is a horse. If and only if, conclusion, it is an animal. No if then. Now, that's false because you have to be able to say it true going that direction. If an animal is a horse, it is a mammal, which was the conditional. That was true. But when you go backwards, if it is a mammal, then it is a horse. That was a converse, and that was false. They both have to be true, therefore it's false. And it's pretty much the same reason as the converse. A dog is a type of mammal, but it's not a horse. So after that, the next ones, number 2 is pretty much easy. They're all true. And this one is just more to making sure you have it written right. So all triangles have 3 sides. If the shape is a triangle, it has 3 sides. Converse, if the shape has 3 sides, it is a triangle. Inverse, if the shape is not a triangle, it does not have 3 sides. Contrapositive, if the shape does not have 3 sides, it is not a triangle. And biconditional, the shape is a triangle if and only if it has 3 sides. All true, a little more straightforward there. You don't have to think as much about that. Okay, on to page 2. All right, here we are on the back, question 3. This is a syllogism, it's a chain rule. The arrow is the symbol for then. So this is if A, then B. If B, then C. If C, then D. If A is true, what can you conclude? So in syllogism, remember excuse me, let me try that again, sorry. If the conclusion of the first statement should become the hypothesis to the next one, here, and then conclusion becomes hypothesis. If that happened, your conclusion is if the first thing, then the last thing. If A, then D. 4, this is a written version of the syllogism. If John reads a book, then Tom watches TV. If Tom watches TV, then Joe eats ice cream. Again, conclusion becomes hypothesis, but this was just 2 statements. One leads to the other. So if the first thing, if John reads a book, what do you conclude? Joe eats ice cream. If you just write Joe eats ice cream, that's fine, because the idea is you already have the hypothesis happening. I just rewrote it as if then to write it out correctly. All right, number 5. How can you show the following statement is false? If you play a sport that uses a spherical ball. Again, the idea, keep the hypothesis true. So name a sport you play. I mean, you don't really play it in real life. That's not a big deal. But what's a sport that you can play but you don't have a spherical ball? I play football, the ball is not spherical. Right, that was my example. I play hockey, does not have a spherical ball. I run track, I swim. Any of those examples would work. The key is that you participate in it, you play it, but the ball is not spherical, or there is not one at all. 6, why are these not sticking? Hold on. And back. Give a counterexample of the following. If a number is divisible by 10, then it is also divisible by 4. Basically, you want a number that will divide evenly by 10. When we say divisible, we mean evenly, with no decimals. And so my example was 30. 30 divided by 10 is 3, but when you divide it by 4, you get 7.5. Any of the numbers 10, 30, the odd multiples of 10 will work. 10, 30, 50, 70, so on. Don't worry too much about these patterns in the sense that these were far more complicated than what you'll see on the test. Okay, the test, if there's patterns, there'll be smaller numbers, more easy to determine if it's just a subtraction or division or something simple like that. So don't forget about those. 9, so we'll go down there. What is the property that allows you to say if x is 5 and y is 5, then y equals 5? Sorry, if x equals 5 and y equals x. Notice that 5 equals x and y equals x. They're both equal to x. Therefore, what that tells you about 5 and y is they're equal. That's transitive property, right? We started with if a equals b and b equals c, then a equals c. It's probably something you saw a while back. Number 10, what property allows you to say the following? If x is 3 and 2x plus 5 is 11, then 2 times 3 plus 5 is 11. That's just substitution because they took x equals 3 and they plugged it in there. Okay? All right, number 11 was an algebraic proof. So we talked about this a bit in class. You give the first given. First thing they do is substitute a 3 in. Okay, substitution property. Then they literally just multiply 4 times 12. Anytime they're doing the math, adding the actual number, subtracting, they actually show it to you. That comes either under substitution or combined like terms. I'll accept either one. Because notice in the next one, all they do there is add 135 and 12 to get 157. So again, if you wrote substitution twice, that's fine. It looks a little weird when you do that, but it still works because I already did it once. Now, what did they do from that step to the next one? The 157's gone, and 256 became 99. You should realize that's subtraction. Then the next step after that, the negative 3 is gone. Y is by itself. 99 becomes negative 33, division. Okay. On the last one, the bit difference here is that they show you the step and then they actually do the step, unlike the previous ones, like those last 2 steps where we didn't see the actual subtraction, we just saw the result. Sometimes they'll actually show you the step first. So we start with given. They distributed the 5, that's what they did there. So distributive property. Then what did they do? They literally show you minus x minus x. So that is subtraction property, but then they actually cancel the x, or subtract the x to get 4x, cancel those x's out. So they do the math, if you will. So again, substitution would accept combined like terms. From 4x minus 10 equals 30, then they did plus 10 plus 10. That's addition property, but then they actually do the addition, substitution. 4x equals 40, they divided 4 to both sides, division property, do the actual division again, substitution. Should be pretty easy, straightforward. You have an answer key, you have a review with me talking about it real quick. Hopefully this should be a good first test. Good luck. See you tomorrow.